Nuclear plants harness the incredible power of nuclear fission to generate heat and energy, which ultimately becomes electricity.
Fission occurs when a neutron hits a larger atom and splits the atom into two smaller atoms.
When uranium atoms in the reactor core split, which releases neutrons and heat, this starts an ongoing chain reaction that generates even more neutrons and heat.
While other power plants burn fuel to create steam and turn the turbine, nuclear power plants are pretty unique. There is no actual fuel being burned to generate electricity, which means that they do not emit any carbon dioxide or greenhouse gases in the process. The only byproducts are actually just energy and heat. There are no additional particles released at all.
In contrast, coal, oil, and gas plants release contaminants including sulfur dioxide, nitrogen dioxide, and carbon dioxide. During combustion, they generate electricity.
So, how do we get from fission to electricity? Well, in summary, water is in large part the answer. The reactor core, which is where uranium atoms are splitting, is immersed into water, and as the chain reaction happens, the heat generated is used to create steam. So as you can see, we took our illegally sourced uranium rods and are showing you a little demonstration of how it truly works. There are two types of nuclear reactors. Both of them use steam to power a generator, but the difference is how they create it. Of the nation's 96 reactors, 32 are boiling water reactors, while 64 are pressurized water reactors. Boiling water reactors heat the water surrounding the nuclear fuel directly into steam in the reactor vessel, while pressurized water reactors heat the water surrounding the nuclear fuel but keep the water under pressure to prevent it from boiling. In a pressurized water reactor, water pumped from the reactor heats a second separate supply of water, which boils to make steam. In both types of reactors, however, the steam does spin the turbine, which drives the generator that produces electricity. This mechanism is the same as the turbine used to generate wind power. The only difference is that steam causes the nuclear reactor's turbine to spin, not wind. After the steam is used, it gets condensed to water so it can be recycled and reused. So, something really awesome that you guys should all know is something known as a decay chain. And decay chains work with a ton of different types of elements, basically. And what is specific to our lesson is uranium-235, and it goes through a ton of transformations, which is why I wanted to include something about it. So basically, a decay chain is a series of decay in which radioactive elements are decomposed in different elements until it produces one stable atom. So it just needs to be completely stable, so it'll go through all of these transformations. And with uranium-235, it goes through a bunch. So it starts off with uranium-235, then it goes into actinium, then to astenine, bismuth, francium, lead, polonium, protactinium, radium, radon, thallium, and thorium, in that order. And there's some scary equation or just example that can be shown of exactly how this works or why it works and whatnot, and that I basically just summarized it. So yeah.